Hi everyone. So now I'm going to show you how we solve question number 2, homework 4. So on this question, the question says the random variable x is in the interval -1 and 1. So we are required to find the g of x. So such that when y equals to g of x and fyy is equal to e to the negative y power times uy. So in order to solve this question, we are required to draw for the fxx and fyy first. So in the graph of the fxx and on the interval negative 1 and 1, you find that the graph should be like this, and there's a point when x equal to 1 plus x over 2 is equals to it's equal to the fyy when y is equal to 1 minus e to the negative y power. So if you set the fxx equal to fyy when at a point when the fxx equal to 1 plus x over 2 is equal to when fyy equal to 1 minus e to the negative y power. So if you set these two equations equals, and then you solve for y in terms of x, and you get y is equal to negative ln of 1 minus x over 2, and which is also the g over x. So because it's given from the question, then you get g of x is equal to negative ln of 1 minus x over 2, and in the range of when x is greater than or greater than negative 1 or smaller than 1, you get g of x should be equal to 0 if you plug in for x is smaller than or equal to negative 1, and when x is greater than or equal to 1, the g of x is equal to the infinity. So now you get g of x is equal to 0 for x is smaller than or equal to negative 1, and g of x is infinity if for x is greater than or equal to 1. So that means when fxx equal to 1 plus x over 2, and when fyy equal to 1 minus e to the negative y power, the x and y are equals when if you solve for y in terms of x, and then you can get the range for the g of x. So we get a graph based on the clues that are given by the professor, and so we set fxx equal to fyy, and we are also given the fyy is equal to e to the negative y power times uy. That's how you get g of x.